Press recording.
All right. Hello, we are group 13. I am Jack.
And I'm Justin.
And I'm Clinton.
The objective we had for this project was we were supposed to do a literature scan on combined cycle power plant operating principles and how the ambient parameters influence the generated power. We were supposed to analyze the existing power generation database and build a model and to predict the power generated output as well. So here, we just imported all the libraries we needed. Then we reread the file. We got the info from it, from info and describe. And then we did the pair plot function from Seaborn Lab to show correlation. The bottom.
This might take a little bit.
Right. Then we also did found the correlation from the heat map as well. Loads.
Oh, shoot.
Hold on. A bit.
Yeah, we're probably gonna restart it.
Oh my gosh, we are 4 minutes, bro.
Has it been fun?
It's still loading.
Crap.
Let me close my shit. This stuff.
Oh, you finally appeared now.
There we go.
Okay, all right, let's keep on going. All right, so the heat map, it finds the correlation from the heat map as well from the bottom, and then we made a copy of it, and then we picked the columns of interest. Then we wanted to convert the four feature columns into standard units, and then we wanted to append those. So.
And then next, what we did is we went and used the data.sample we would sample values from the 9,568 rows from the ATV, AP, and RH columns. And we get the first 66% to train the model, 66.6%, and then we use the rest of the 33.33% to test the training model. And then next is we're using the trained and test model to then put in our X and Y values, which is the columns and the numerical values within the columns. So we have 4 and then 1 for the last column, which is the predicted output. And then next we're using this to transpose and stack a row of ones vertically to the X train and Y X test set. And we define data in order so that we may be able to we wanted to get zeros in the first matrix so that we can multiply those by the next matrix of values. So then we implement the data and the gradient descent algorithm with our function. And next we test the model on the training set when we plot the values that we get from the training set, which is training our model to get better at predicting the output values. And then now we use the test model on the test set. And we use those 2 test and training sets to plot the output versus the number of iterations, which was 10,000. Which gives us this graph. And then we use the mean square root error and to basically just test find the error value within the training model and the test model, which is saying how close or how much error there is within our predicted outputs.
And now all of that was we have using libraries. Now we started using libraries. First, we show the power output data set by showing the first 5 rows. And then we assign the 4 feature columns to a variable named X and print those. So we only want to see the first 4 and not the predicted outcome. And then we scale the 4 columns using Skylearn. And we input that into X. And then from Skylearn model, we test and train all the different ones for X and Y. And then we use the linear regression from Skylearn to find LM. And then we use that testing to test on the training set. And then we also use it to plot the test set. And we see that the line is close enough to touching most of the things. So we do see linear regression. And now we use Skylearn to find the root mean square error and also on the test and the training set. And then we define the function as predicting power output. And we use inputs of AT, B, AP, and RH in the function to calculate the predicted outcome. The first 2 we printed, those 2 are to check if our predicted outcome function actually is close enough related to the actual numbers. So those are rows 1 and 2 on the CVS file. And then the final 5 are the actual functions we're trying to find. And those are the predicted outcomes, so they're not exact, but they're close enough based on the error we found earlier.
I did the comments and the model quality.
Me and Clint, we actually built using out libraries, and we also did the predicting power output function and plugging the values in.
And Jack also assessed the model. So props to all of us. That's all, folks. Thank you for watching.
Correct.
That's